Hello guys, myself Yusra Momin. Today Group C of Government Polytechnic Pune is going to present mini project based on CAM and followers of subject theory of machine.
Hello everyone, here I am Vedika Lumde going to present along with my friends about CAM and follower. In this presentation, we are going to cover all the points like introduction of CAM and follower, its terminology, some related definitions, their types, as well as advantages and disadvantages. Let's start with introduction. So, what is CAM? Cam is a mechanical member which is used to transmit a rotatory motion converting into reciprocating or oscillatory motion of another mechanical member called as follower. They are in contact with each other. These cam and follower systems are widely used in all modern machines like internal combustion machines, in textile machines, paper cutting machines, as well as special cutting machines. The shape of the cam is decided by the motion to be imparted to the follower and the surface contact between them. That's why the follower's motion is usually predetermined. Now, this is the diagram of cam terminology. Here you can see the direction of the follower's motion, which is in oscillating, or we can say it's in a reciprocating motion. Here, the follower is roller type follower. We will discuss the type deeply in next point. You can also see the other points like base circle, cam profile, pitch circle, and many more. So for more clarification, let's see the standard definitions of these terms. See, first one is base circle. It is the smallest circle that can be drawn to the cam profile from the center of the rotation of the cam. Next is cam profile. What is cam profile? It is the actual working contour of the cam with which the surface of the follower is always in contact, and it transmits the required motion to the follower. Third one is trace point. It is the point of the follower which is used to generate pitch curve. Trace point represents the point of the knife edge in the case of knife edge follower and the center of the roller in case of roller follower. It is the point on the pitch curve of the cam having maximum pressure angle. Then pitch curve. While drawing the cam profile, it is assumed that the cam is at rest and the follower rotates around the cam and its velocity or relative velocity. The path traced by the trace point is called the pitch curve. Next one is prime circle. It is the smallest circle drawn to the pitch curve from the center of the rotation of the cam. Now the list or stroke of the follower. It represents the maximum travel of the follower from base of the circle to its topmost position. Next one is pressure angle. What is pressure angle? It represents the included angle at any point on the pitch curve between the line of the motion of follower and normal to that point on the cam profile. This angle is of great importance in designing cam profiles. Now the last one is cam angle. What is cam angle? It is the angle of rotation of cam for definite displacement of the follower. The angle turned by the cam when the follower lifts from base circle up to its maximum rise is called as angle of rise. When there is no displacement of the follower, the angle turned by the cam is called cam angle. So here we are done with the introduction of cam and follower with the help of the diagram. Now let's discuss the second topic, that is types of cams. So basically cam can be classified in three ways according to their shape, according to the follower's motion, and third one is that manner of constant of the follower. According to shape there are three types of cam. First one is disc, or radial cam. In this type of cam, the position of the follower depends upon the position of the axis of the cam. The follower reciprocates perpendicular to the axis of the cam. Second one is cylindrical cam. In this type of cam, the follower reciprocates or oscillates in the same plane as that of the axis of the cam. The cam has a groove on its circumferential surface as shown in figure. And the last one is wedge cam. In this type of cam, the cam has wedge or a groove. You can see that grooves in figure. The cam has reciprocating motion and the follower may reciprocates or oscillate. Now, according to followers' motion, there are again three types. First one is dwell, rise, dwell cam, in short DRD cam. Second one is dwell, rise, return, dwell cam, that is DRRD cam. And third one is rise, return, rise cam, in short RRR cam. In first type, you can see the graph. The x-axis shows the cam angle and the y-axis shows the follower's displacement. The dwelling of the cam is followed by the rise and another dwell period. Next one is DRRD cam. Here again x-axis shows the cam angle and y-axis shows the displacement of the follower. This type has the rise and return preceded followed by dwells. Now the last two type is RRR cam. In this type it has only the rise return rise contour and there is no dwell. See the diagram. The displacement of the follower, it rises and then return. There is no dwell position. This type has very limited use in machinery.
Thank you, Vedika. Hello everyone, I am Sakshi Karoke. I am going to talk about follower, its types, and types of follower motion and also the displacement diagram. The follower is that type of member which converts rotary motion of the cam into reciprocating or oscillating motion. That is, when cam rotates, follower will move in up and down direction. So this cam and follower mechanism can be used in many applications like inlet and exhaust wall of IC engine. Similarly, this mechanism also used in paper cutting machines and also in lathe machine. Let's see classification of followers. There are three main types of follower, that is according to their shape or surface of contact. The second one is according to type of motion of follower and the last one is according to line of motion of follower. Let's see type of follower according to their shape. They are subdivided into four classes which is first one is knife edge follower, second one is flat faced which is also called as mushroom follower, then we have roller follower and the last one is spherical follower. Here, whatever examples I have given based on surface of contact, these are all examples of reciprocating follower. Let's start with first kind of follower which is knife edge follower. Then in case of knife edge follower, the point of contact of follower and cam is it in shape of sharp edge. So here as we can see in the first diagram, the follower is having sharp edge and that's why it is called as knife edge follower. It is simplest follower in construction. It is this type of follower not suitable for precision application, that is where timing is more important. We can't use this type of follower there. This is mostly used in paper cutting operations. Next we have flat faced follower which is also called as mushroom follower. As we can see in the third diagram, the point of contact or the surface of contact with the cam here, the follower is flat faced. It is having flat surface. So such kind of follower can be used in precision applications. So this is all about flat faced follower. Next we will see roller follower. Now in case of roller follower, the point of contact between the follower and roller is in the form of line or just a point. So we can say that cam and follower form higher pair here. Because of the roller present here, the motion becomes more smooth as we can compare to knife edge follower. This type of follower can be operated at very high speed like in walls of IC engine. So this was regarding roller follower.
Next we have a spherical follower. We can see in last diagram as this is very much clear that in case of spherical follower, the surface is curved, and again when we give motion to the cam, follower will move reciprocating direction. Next type of follower is according to motion. We have two kinds of follower, which is reciprocating follower and other is oscillating follower. Reciprocating follower is same as previous examples we have seen of the four different kinds of follower. They were all reciprocating. That means when cam is rotating, this follower will move in up and down direction. Next we have oscillating follower. In this type of follower, when the cam is rotating, follower will oscillate. That is, it won't be completing one complete revolution. It will just oscillate. That is, it would be moving like a pendulum. So here is the third classification based on line of motion or axis of cam and follower. Here we have two kinds of follower. First one is radial follower and second one is offset follower. As we can see in first diagram, if we have axis of cam and axis of follower passing through the same line, then it is called as radial follower. For offset follower, it is very much clear from the second diagram that in case of follower, the axis of cam and follower, they are not passing through the same line. It means there is some distance between two axes and that distance is called offset. Hence, the classification of follower is over. Now, we will discuss about types of follower motions and displacement diagrams. When cam rotates at angular velocity, the follower during its travel may have one of the further motion. First one is uniform velocity or uniform motion. Second one is simple harmonic motion, that is SHM. And the last one is uniform acceleration or retardation. Let's see motion of follower with uniform velocity. In this displacement diagram, base represents angular displacement of the cam in degrees, that is cam angle. In uniform velocity, slope is constant. The line BC and DA shows dwell period in which there is no follower motion, and the line AB and CD represent rise and return slope respectively with uniform velocity. Here we have SHM, that is simple harmonic motion. It can be described as an oscillatory motion in which acceleration of the follower at any position is directly proportional to the displacement from the mean position. The construction involves drawing a semicircle and dividing it into same number of parts as the cam displacement angle. The diameter of semicircle is equal to rise or fall of the follower. And here the last is uniform acceleration and retardation. Now, if the follower velocity is increasing at a constant rate, then it can be called as uniform acceleration, as we can see in the diagram. First half stroke follower moves with follower uniform acceleration, and if follower decreases its velocity by equal amount in equal intervals of time, it is called uniform retardation, which we can clearly see in remaining half stroke. Thank you. Now I will hand it over to
Hello everyone, I am Ashwini Lokre. Let's we discuss how to draw the diagrams of cam and profile with the help of some examples. For that, we must have to notate some points like the displacement diagram of the follower is to be drawn. Second, the cam is assumed to be stationary. Third, the follower is assumed to move around the cam. The detailed procedure of drawing the cam and profile for different types of followers is explained in the following section. Let's we discuss one example. Example number 1. To draw the profile of a cam operating a knife edge follower from following data. Data is follower to move outwards through 40 millimeter during 60 degree of cam rotation. Second, the follower dwell for next 45-degree. Follower to return to its original position during next 90 degree. follow to dwell for rest of the rotation. The displacement of the follower is to take place with simple harmonic motion during both outward and return stroke. The least radius of the cam is 50 mm if the cam rotates at 300 rpm. This is our question. Here in this question, the follower is of knife edge follower to move outwards through 40 millimeter during 60 degree of the cam rotation. First we write all the angles. So theta 0 is equal to 60 degree. Follower dwell is 45 degree. So theta w, that is dwell angle, is 45 degree. In the same way we have the return angle of 90 degree. So theta r is equal to 90 degree and dwell for the remaining is 165 degree. Summation of all these angles is 360 degree. Then the stroke of the follower is 40 millimeter and minimum radius of the cam is 50 millimeter. Here the motion is simple harmonic motion. Let's we start our solution. First, we have to make a displacement diagram, and for the displacement diagram we have to take a small scale factor, and that scale factor we are converting our degrees into centimeters. So for that I take the scale 1 centimeter is equal to 20 degree. So 360-degree line is of 18 centimeter as per of my scale on x-axis, and on y-axis we plot the stroke of the follower which is of 40 millimeter. So draw the line upward from the left side of 4 centimeter. That is our stroke of the follower. Now complete that rectangle and divide x-axis into three segments. First is for the outstroke angle which is of 60 degree. So 60 by 2, that is our 3 centimeter, because we give the scale on the x axis, that is 1 is to 2. So 60 by 2 is equal to 3 centimeter, the length of our outstroke. Then the next is our followed dwell period is of 45 degree Celsius, so it is of 22.5 centimeter, and 90 degree of return stroke is 4.5 centimeter line. Now we have to divide outstroke angle and return stroke angle into six equal parts. So for that, draw the two inclined lines dividing the outstroke angle and return stroke angle into six equal parts and name them as 1, 2, 3, 4, 5, 6, etc. For outstroke, the equal parts are from 1 to 6 and 6 to 12 for the return stroke. Now take the now take that projection of that inclined line on the x-axis. Then next step is this diagram is of simple harmonic motion. So by taking the midpoint of this stroke, we have to draw one semicircle. That is our semi-harmonic circle of radius 2 centimeter. Then divide this semi-harmonic circle into 6 equal parts. So 180 by 6. So each part is equal to of 30 degree, and name that parts from the bottom to top as 1, 2, 3, 4, 5, 6. Then draw the horizontal lines parallel to the x-axis from each division. So line coming from 1 intersects the vertical or the division line at A. Projection line coming from 2 intersects the vertical line 2 at B. Horizontal line 3 will intersect the vertical line 3 at C. Same procedure for all these points up to 6. Join all these intersecting points by a smooth curve, and this is our simple harmonic curve that we are obtained for theta 0 is equal to 60 degree. That is our outstroke. Then dwell is of 45 degree, so the displacement gives us a horizontal line at the topmost position. Then for the return stroke, the similar or the same points will be there for the return stroke. So mark that point on the return stroke, on the length of the return stroke, and join all these points by a particular smooth curve for the return stroke. And here that curve represent our displacement diagram during return stroke. And here we complete our displacement diagram for the simple harmonic motion. Now for cam profile, to draw the cam profile, first we have to draw a base circle of radius 5 centimeter. Then divide that circle by taking the axis line. Then also divide the base circle into 6 equal parts. So parts of 10 degrees Celsius for outstroke, because our outstroke is of 60 degrees Celsius, so each part is equal to 10 degrees Celsius. Then remaining is of 45 degree is of our dwell. Then our return stroke angle is of 90 degree, so divide the return stroke angle 90 degree into 6 equal parts, so each part is equal to the 15 degrees Celsius. Extend all these divided lines, then measure the distance from the base circle, from 0 to a 1, 1 0 1 to a, 2 to b, 3 to c, and measure that distance and transfer it on the division of the outstroke. Similarly, for this similar procedure we have drawn from the return stroke. Take the distance 6 to G, 7 to H, 8 to I, and transfer it on the division of the return stroke angle, and at last draw all that points by a smooth curve. And here we complete our cam profile for the knife edge for this question. Let's we discuss the second question. A cam operates a roller follower axis passing through the axis of a cam. The specifications are: minimum radius of the cam is 25 millimeter, lift of follower is 30 millimeter, diameter of roller is 15 millimeter, angle of lift is equal to 120 degrees Celsius with simple harmonic motion, outer dwell angle is of 30 degrees Celsius, angle of return is 150 degree with uniform acceleration and retardation. Draw the cam profile. Here this is our question. Here was the radical roller follower moving with simple harmonic motion during uniform acceleration and retardation during a return stroke. So this is our problem statement. Here the follower type is of radial roller follower. Minimum cam radius is of 25 millimeter, which will be the radius of the base circle. Stroke length is of 30 millimeter. Roller radius is 7.5 millimeter. That is, we have given the diameter of 15 millimeter. And during the rise of the follower, cam rotates of 120 degrees Celsius. Then dwell period is of 30 degree and return stroke is 150 degree, and the follower's motion is uniform acceleration and retardation. So theta 0 is equal to 120 degree, theta w is equal to 30 degree, and theta r is equal to 150 degree. This is the given data of that question. For the solution, let's we start the solution. First, as per the same procedure, first we have to make the displacement diagram. And for displacement diagram, we have to take a small scale factor, and that scale factor, as we are converting our degrees into centimeters. So on x axis I take the scale 1 centimeter, 1 is to 2, that is 1 centimeter is equal to 20 degree. Here on y axis we have to plot the stroke of the follower, and on x axis we have to plot the cam rotation, that is our angle theta. So for y-axis, we take the scale 1 is to 1 and plot 30 millimeter. That is our stroke of the follower. Now on the x-axis, we divided x-axis into three segments. First is of our outstroke angle, which is of 120 degree. Take the scale 1 centimeter. 1 centimeter is equal to 20 degree for outstroke angle. So 6 centimeters gives 120 degree. So theta 0 is equal to 120 degree is equal to 6 centimeters. Now next dwell period is of 30 degree. So it is of 1.5 centimeters, because we give all the values on x axis into ratio of 1 is to 2. For the return stroke, The length is of return stroke is of 7.5 centimeters. Now we have to divide the outstroke angle and return stroke angle into six equal parts. So draw inclined line, divided the outstroke angle and return stroke angle into six equal parts and name them as 1, 2, 3, 4, 1 to 6 for the outstroke angle and 6 to 12 for the return stroke angle. Then by taking the midpoint of the stroke, draw a semicircle, that is our semi-harmonic circle of radius 7.5 millimeter. Divide the semi-harmonic circle into six equal parts. So 180 by 6. So each division is equal to the 30 degrees Celsius. Name that divided circle and that points from bottom to top like 1, 2, 3, 4, 5, 6. And then draw the horizontal line parallel to the x-axis. So the line coming from 1 intersects the division line 1 at A. Projection line coming from 2 intersects the line 2 at B. Projection line coming from 3 intersects the 3 at C, and so on till the 6. Join all these intersecting points by a smooth curve, and that will represent the displacement diagram during outstroke. Then our dwell is of 30 degree, so the displacement diagram gives the horizontal line at the topmost position. Then for the return stroke, here in this question there is acceleration and retardation. So by solving the equation v is equal to u plus at, we have marked the point of the return stroke, and then join that point by a smooth curve and name them as H, I, J, K, L, M, and N. And here we get our displacement diagram for the return stroke also. And here we complete our displacement diagram. Now for the cam profile, the first thing is to draw the base circle. And the here in this question the base circle is of radius 25 millimeter. Next is to draw the prime circle. So prime circle radius is equal to base radius and roller radius. So the base circle radius is of 25 millimeter and roller radius is of 7.5 millimeter. So 25 plus 7.5 is equal to 32.5. So draw a prime circle of radius 32.5 centimeter. Sorry, 32.5 millimeter. Then draw the axis of the cam, and since the follower is radial, the line of the center line or the line of the action is on the center. So now draw the roller. It's on the roll. It's on the lower position of the circle. That the roller and the circle is must be in contact on the lower side of the roller, and the upper side of the circle is in the contact. Then the divide the prime circle into number of segment. So first is of 120 degree of outstroke. So next is dwell period is of 30 degree, and next is 150 degree of return stroke. Now in displacement diagram we divide the outstroke angle in and return stroke angle in six equal parts. So divide the cam circle into six equal parts of outstroke. So each division is of 20 degree. Then there is a dwell of 30 degree. Then we have to divide return stroke angle into six equal parts. So 150 by 6. So each part is equal to 25 degree. Then mark that division on the prime circle. Extend that all the divided lines. Then measure the distance from 0 to A, 1 to B, 3 to C, 4 to D, uh, of the outstroke, and similarly the distance from 6 to H, 7 to I, 8 to J of the return stroke also, and mark that distance on that divided lines of the of that of that angle, and then draw the roller of all that installations. And then at last we have to draw the the smooth curve, smooth freehand curve tangent to all these circular rollers. And here we complete our cam profile for the roller follower. And in this way we have complete our displacement diagram as well as cam profile for that, for this question. Thank you.
Hello everyone, I am Varsha Vani and now we are going to see the advantages and disadvantages of cam and follower. Advantages of cam and follower are: first, a wide range of linear motion are available from cams and followers. Second, it can also absorb shock than normal and can reduce the distortion. Third, they are highly versatile. Advantages of knife edge follower. It is simplest follower in construction. Advantages of roller follower. First, rate of wear is less. Second, it is used where more space is available. Third, it has more life. Fourth, it is used in oil engines and the aircraft engines. Fourth, flat faced follower advantages. First, the side thrust between the follower and the guide is less. Second, it does not have a problem of jamming. Disadvantages of cam and follower. The point between the cam and the follower is in contact with the line that is easy to wear. Second, it is expensive for the setup of equipment. Disadvantage of knife edge follower are: first, its point of contact is a sharp edge and has small area. Second, which results in more wear and tear. Third, it is used for small applications. Fourth, it produces considerable thrust between follower and the guide. Disadvantages of flat-faced follower. It is used where space is limited, such as in cams which operates the valves of automobile engines. Second, surface stresses are high. Applications of cam and follower. First, internal combustion engine to close and open the outlet valve and the intake valve. Second, in printing machinery, the mechanism of cam and follower screen helps the screen to be printed. The push helps to take the position where the printing will be done, and the pull helps to print out that. Third, in textile machinery, the mechanism of cam and follower helps to stitch clothes by a push and pull. Fourth, the screw pieces of machinery. Fifth, gear cutting machineries. And a day-to-day example is wall clock. Working of cam and follower. A cam and follower is a mechanism, is a profiled shape mounted on the shaft that causes a lever or follower to move. Cams are used to convert rotary motion to linear motion, or we also can say it as reciprocating motion. As the cam rotates, the follower rises and falls into a process called as reciprocating motion. The follower maintains contact with the cam through the force of gravity or by a spring, and the total range of movement is produced by the cam is called as stroke. And now we have seen till now the introduction, terminology, types of cam, follower, types of follower, motion, construction, principle, and working. And now we have the result. A cam and a follower is a component that is intrinsically tied to the cam. Second, cam exists in many applications as well. Third, the goal of cam is to convert rotary motion to linear motion. Thank you.